Hey everyone, welcome back to this channel. In today's video, we are diving deep into one of the most powerful ensemble learning algorithm in machine learning, AdaBoost. We'll explain how AdaBoost works in detail, its key concepts, and even walk you through an implementation during using a real data set, the housing price dataset. By the end of this video, you will have a solid understanding of AdaBoost and how to apply it to the real world problems. Let's get started. So to start, what is AdaBoost? So AdaBoost stands for adaptive boosting. It's a type of ensemble learning techniques that combines multiple weak learners to create a stronger and more accurate models. But what's a weak learner? A weak learner is simply a model that performs slightly better than random guessing. So AdaBoost takes a bunch of these weak learner, typically decision stump, which are just one level decision tree, and combine them to form a more powerful predictive model. So how does AdaBoost works? So step one, it's train a weak model. And AdaBoost start by training a weaker learner of the data. Initially, all the data points are given equal weights. Step two, identify errors. The model's performance is evaluated and the data points that were misclassified are given more weights. This means the model will focus more on how to predict example in the next round. Third, it train the next weak model. So the AdaBoost then train a second model, but now it's focused on the previous classification model. And this is the diagram. And this cycles continue for the number of iteration. And the fourth step, it's combine the models. So finally, AdaBoost combine all these weak learners into a weighted sum. Each models contribute its weight based on its accuracy. As a result, each models corrects the mistake of the previous one, leading to stronger overall model. Now let's get into the code. We'll be using the housing price dataset, which contain various features like the number of rooms, location, and age of house. And our goal is to predict the house price. We'll apply AdaBoost to this regression problem. Now let's start by importing the necessary libraries. And here we are importing typical libraries you need: the NumPy for data manipulation, Pandas for data handling, AdaBoost regression from scikit-learn for the AdaBoost algorithm, and few other for model evaluation plotting. Next, let's load our housing dataset. And you can see you can use a dataset like the one from scikit-learn or import your own. For simplicity, I will use the California housing dataset, which is available in scikit-learn. So as you can see, this dataset contains feature like let me create a data frame and let's see the first 5 rows. As you can see, this data set contains feature like median income, average number of rooms, average occupancy, along with the target variables, which is the median house value. Now let's split the data into training and testing set so we can train our models and evaluate properly. Now, now comes the main important part, the implementing of AdaBoost. We'll use the decision tree regression as the base model and then the AdaBoost regressor to boost its performance. Let me run this cell. So we have a base model of decision tree regressor. I've called the AdaBoost regressor to boost it and fit the our X and Y data into it. Also, we initialize the decision tree regression with maximum depth of 3, which means it's a weak learner. Then we'll pass its base model into Ada regression and set the number of estimator to 50 and train it on training data. Now let's evaluate how model is performs by predicting the house price on the test data. Run this. and calculate the mean square error. So let me see what's the value. So it's almost 0.7, which is fairly good. Now, finally, let's visualize the prediction by plotting the predicted value against the actual value. Yeah. So this our plot shows how our model's prediction matches the actual values, and the closer the points are to the red line, the better model is performing. Also, let's see other visualization. So in this one, each point represent an actual versus predicted pair, and the red line is the reference line, right? Where the predicted price perfectly matches the actual prices. Now, the another plot is the residual plot, which will show difference between the actual value and predicted value, also known as the residual. And this plot helps us to check if there are any systematic pattern in the residual. Ideally, residual should be randomly scattered around the horizon line at 0. And if we see any trend or pattern, it could indicate issue like model bias or variance. Now, one interesting property of Ensemble model like AdaBoost is that they can provide insight into feature importance. And let's note the feature importance to see which features contribute most to the model prediction. And as you can see, the median income here is is the most important features in predicting housing price. And the most this helps to understand which aspect of the model, which aspect of the data our model is focusing on most. Also, let me run this plotting curve. So this is the learning curve, and it shows how the model performance improves with more training iteration. So more training iteration. So these are the number of training samples, and this is the mean square error. And as you can see, it is linear, and it's improving as we're adding more training iterations. So this learning curve shows how the error decreases when we train with more data. So to summarize, AdaBoost can significantly improve the performance of a weak learners, and by visualizing the model performance using plots like predictive versus actual scatter plot, residual plots, and feature importance, we get valuable insight into how the model is performing. These visualizations help us to better understand the model's strength and the areas of improvement. Thank you for watching. If you found this helpful, don't forget to like, subscribe. See you in the next video. Thank you.